Hello. Today we are going to learn to solve quadratic equations by square roots. So you guys have been working with quadratic equations, but before we begin, we want to review what we did before spring break, which is simplifying radicals, because in your final answers today, you're going to have to simplify your radicals. So the first thing you want to do is write this list of perfect squares, right here. 1, 4, 16, 25, etc. Because that's going to be helpful when you guys solve these problems. So the first step is to look at the number inside your square root and check if it's not a perfect square that falls on this list. So 48 does not fall on the list. If it does, you know your answer is not going to have a square root symbol because it's perfect and your answer would just be whatever that square root is. So the square root of 48, not on the list, so we go halfway to that number. Halfway to 48, we know is around 16. So we ask ourselves, starting here, then we'll go to 4, and then we'll go to 1, is it a factor of 48? So I go to my calculator. 48 divided by 16, and it works out perfectly. So I rewrite the radical as the square root of 16 times the square root of 3. We do this because 16 fell in the perfect square list, and the square root of that is a perfect 4. Whoa. The root 3 is the leftover, and that's your final answer. Number 2, 64. Does it fall on the list? Yep, it does. So I don't need to go through that process. The square root of 64 is 8 because 8 times 8 is 64. Also, use a calculator. 64, square root it, you get 8. Number 3. Anytime you have a negative inside your square root, in Algebra 1, we're going to say no solution right now. Eventually, you're going to learn about something called imaginary numbers, and that deals with the letter I to represent that it's imaginary. For now, no solution. Okay. Number 4, it has a number outside of your square root, so we'll deal with that at the end, but for now we're going to simplify the square root of 12. Go to your list. Halfway to 12 is around 4, so start with that number. Does it work out perfectly? Yes, 12 divided by 4 is 3. So we go back to our list, and we rewrite 12 as the square root of 4 and the square root of 3. Square root of 4 is a perfect 2, and the square root of 3 is left over. But don't forget to bring this number in front down. It's being multiplied by the number on the outside of the square root, so this simplifies to negative 4 root 3. Okay. So now we're going to learn the method called solving by square roots. Let's write down the methods we've learned so far. We've learned to solve or find roots, zeros, or x-intercepts. They all mean the same thing by graphing. And we looked at where the graph touched the x-axis to get our answers for what x equals. Then we also have by factoring. Or we could say algebraically. And that's when we had to get our answers. Let's look at an example like x squared plus 8x plus 16. Set it equal to 0 if it wasn't, and then we would factor. And since these are the same, you would get one answer. So You set it equal to 0, and we get x equals -4. And that's how we solved by factoring. Now, we're solving by, I'm going to add the third one, square roots. And that's what your homework is on today. So when you're solving by square roots, your goal is to get the term that's squared alone. So in this case, I'd want to get x squared alone. Sometimes there's a parentheses with x plus or minus a number or whatever's inside the parentheses, and you want to get that piece alone. And in this case, number 4, it already is. We'll go over a couple more cases, but for now, keep in mind the goal is to get x squared alone. So number 1, here's x squared. How do I get rid of everything else around the x squared? So step 1 in this case, add 27 to the other side. Now we have 3x squared equals 27. The x squared term is still not alone, so your next step, divide by the 3. And we get that x squared equals 9. In order to undo something that is squared, a term that is squared, we square root that term. But when you square root one side, you have to square root the other. The square root of x squared is just x itself. The reason for that, I'll do it on the side here. Let's put it on this side. Backspace a couple times. X times x gives us x squared. So that's why the square root of x squared is x. So back to this problem. When you square root both sides, you get x on the left. And the square root of 9, it falls perfectly on that list. Oh, I actually missed it. Should be there. Is 3. And we have to consider that it could be positive or negative 3. Always, anytime you guys take a square root, when you guys are actually writing it in, you have to consider there's plus or minus in front of your answer. The reason for that, I'll do that on the side as well. 3 times 3 gives us positive 9. And negative 3 times negative 3 gives us a positive 9. So we have to incorporate both answers, the plus and the minus. Here's another one. We want to get x squared term alone. Add 10 to both sides. And we get x squared is equal to 0. We square root both sides of the equation. On the left, we'll get x. And on the right, the square root of 0 is just 0. 0 times 0 gives you 0. But there's no plus or minus because we don't write 0 as positive or negative. So there's one answer here. Number 3, getting x squared term alone, you want to subtract 11 from both sides. We get 5 on the right, negative 5x squared on the left. To get the x squared term alone, we want to divide by the coefficient, negative 5. And you will be left with x squared equals negative 1. Take the square root of both sides. Remember, it's plus or minus, but wait, we notice that the inside of the square root's negative, and therefore we can actually stop there and write no solution. Again, later on you'll learn that you have to keep going with those problems. For now, it's no real solution. Number 4, this whole piece is the squared term. I don't need to get rid of the 1 inside. It's everything in parentheses. Is that alone? Yep, it's already alone. So now your next step is just square rooting both sides. and it's plus or minus. The square root of x minus 1 squared is again just that piece inside. So x minus 1 equals 25 is a perfect square because 5 times 5 is 25. So plus or minus 5. Here's where the issue comes in. Not an issue, just another step you're going to have to take. We know that x minus 1 is either positive 5 or negative 5. We have to split this up into two algebraic equations. It's not difficult, it's just something you need to remember because there's two possible answer choices. So the first possible answer choice is that x minus 1 is equal to positive 5. The second answer choice is that x minus 1 is a negative 5. So now when you solve both, you're going to get two separate answers. On the left, when you add 1, you get x is equal to 6. On the right side, if you add 1 to both sides, you get that x is equal to negative 4. And those are your two answers. We did not have to do two separate equations up here because x was already alone. Just a quick note, you can leave your answer as plus or minus 3. You can also write x equals 3 and x equals negative 3. Okay. Number 5, I'm going to add 4 to both sides. At this point, you might want to pause the video and try them on your own. They will become answers where you're going to have radicals in the answers. So if you're having difficulty simplifying radicals, keep watching. From here, divide by 2 on both sides. X squared equals 20. We now square root both sides, and we consider that it's plus or minus. Okay, 20 is not a perfect square, so we go to our list. Halfway to 20 is around 9. So we're going to start by dividing by 9. Go to your calculator. 20 divided by 9. Nope, doesn't work. Go to the next number on the list. 20 divided by 4 works perfectly. So this is equal to plus or minus root 4 times plus or minus 5. Simplify that further. X is equal to, the square root of 4 is perfect, so it's plus or minus 2, and 5 is your leftover. A lot going on here. It's just extra steps in getting your x squared term alone. Notice with this problem, the parentheses is not being squared. So we're not trying to get the parentheses alone. This is slightly different because we still want to get the x squared term alone. So there's a couple ways to do this. You can distribute. I suggest that you keep the parentheses there, don't distribute, and kind of get rid of the 2, and I'll show you how to do that. Again, the option of distributing is possible. Step 1, get rid of the 22 by adding it to both sides. Okay. Instead of going through and distributing, we are going to divide by 2. You'll be left with x squared minus 2 equals 28. Now we almost have the x squared term alone. Get rid of the 2 by adding it to both sides. And you're left with x squared equals 30. To get x alone, square root both sides, plus or minus, and simplify. ask yourself, can I simplify the radical of 30? So let's go to our list. 30, halfway to 30, we're going to say is a 9, around 9. It's not 16. 16 goes over. So 30 divided by 9. Nope. Go to the next number on the list. 30 divided by 4. Nope. The last number is 1. Anytime the only number it's divisible by is 1, then your radical is already simplified as much as it could be. And that's it.